Hello students, I am Laxman Singh Rawat, PGT Chemistry at CIS Dasua. Students, I hope you are enjoying this method of teaching learning that CIS Dasua has come up in these hours of crisis. CIS Dasua's e-learning is helping students to study at their home so that they do not lag behind due to this lockdown. We will start with a new chapter, the structure of atom. Since we have new chapter starting today, first we will carry out the introduction of the chapter. We will recap some of the facts that we have studied. Then we will also discuss about the subatomic particles, their discoveries and their importance in the structure of atom. Now that we have completed our first chapter, that is the basic concept of chemistry, if you have any doubt in that chapter, you can please get back to me. Now, we will be starting with new chapter, the structure of atom. In the previous chapter, we had studied that atoms are the fundamental building block of matters. And the word atom itself has been derived from Greek word atomio, which means non-divisible or uncuttable. And Dalton's atomic theory regarded the atom as the ultimate particle of matter. In this unit, we shall study about the experimental observations made by scientists which established that the atoms can be further divided into subatomic particles, that is, electrons, protons, and neutrons, a concept which was quite different from that of the Daltons. Daltons considered the atom to be indivisible particle, whereas the experimental observations made some other revelation which led to the discovery of subatomic particles. That means the atom itself is made up of smaller particles. There are a large number of subatomic particles, but we shall only consider a few of these fundamental particles which we normally address in the chemistry, the electrons, protons, and neutrons. Now, after the discovery of the fundamental particles, the major problem before the scientists was to account for the stability of atom. Also, how to compare the behavior of one element from that of other, both in terms of physical as well as chemical properties. Then, another problem was how to explain the formation of different kind of molecules by the combination of different atoms. Then, to understand the origin and nature of characteristic of electromagnetic radiations absorbed or emitted by the atoms. These were few of the problems which were experienced by the scientist after the discovery of the fundamental particles. Now let us try to understand subatomic particles. In fact, Dalton's atomic theory could explain the law of chemical combinations. The various laws were explained by the Dalton's atomic theory. However, it failed to explain the result of many of the experiments. One of the fact was it could not explain the electrical nature of matter. That is, when the substances like glasses or ebonite were rubbed with silk or fur, they generated electricity. Also, Dalton's atomic theory failed to explain the discovery of subatomic particles. The complexity of atom was further revealed with many of new observations like the discovery of cathode rays, positive rays, X-rays, isotopes, isobars, many of these. Various scientists contributed toward the modern theory of atomic structures. Especially, we need to mention the work of J.J. Thomson and Ernest Rutherford, who laid the foundation of the modern picture of atom as we see it now. In around 1830, Michael Faraday showed a quantitative relationship between the amount of electricity passed through a solution and the amount of substance deposited or liberated at the electrode. So basically, this experiment showed the quantitative relationship between the electrical energy and matter. And these results suggested that the electricity are particulate in nature. By around 1850, many scientists, including Faraday, started to work on the electrical discharge in partially evacuated tubes called the cathode ray discharge tubes, which we have given in the figure also. Now, this cathode ray tube is made up of glass with two metals attached at the end of this cylindrical tube, and these are called the electrodes. The electrical discharge through the gases could be observed only at very low pressure and when the applied voltage is very high. The pressure inside this tube could be adjusted by evacuation through the vacuum pump which is attached to it. When sufficiently high voltage is applied across the electrode, the current starts to flow through these vacuum tube in the form of stream moving from the negative electrode to the positive electrode, that is from cathode to the anode. Now let us try to understand what is cathode ray. When sufficiently high voltage was applied across the cathode ray tube, current starts flowing through the cathode ray in the form of stream, moving from the negative electrode to the positive electrode. Since these rays were generated at the cathode, these were called the cathode ray or the cathode ray particles. Further, the flow of current from the cathode to anode was checked by making holes in the anode and coating the tube behind the anode with phosphorescent material like zinc sulfide. And when these cathode ray passed through the holes in the anode and struck the zinc sulfide coating, a bright spot was developed. This shows that the cathode ray are generated at the cathode and they pass toward or they flow toward the anode. After a series of experiments, the following characteristic of cathode rays were pointed out. The first one is the cathode ray starts from cathode and moves toward the anode. Since the glow is seen behind the anode, that means the rays must be generated at cathode. Okay? That's why we can say that the cathode ray starts from cathode and move toward the anode. And when the anodes were perforated, it was seen that the glow was seen behind the anode when the screen behind the anode was coated with fluorescent material. Now, these rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials, that is fluorescent or phosphorescent, which glow when hit by them. These are invisible rays, but we can make their presence felt by fluorescence or phosphorescence. When these cathode ray hit the fluorescent or phosphorescent material, they glow at the spot of the collision. Then these rays travel in straight line as they cast shadow. If we place an opaque object in their path, if we place any opaque object, let's say a material made up of, let's say, lead in between the cathode and anode, it is seen that a shadow will be seen on the side of the anode, which means that these rays travel in straight line. If they do not travel in straight line, the shadow will not be cast. Now, in the presence of electrical field, they move toward the positive electrode, suggesting that the cathode ray consists of negatively charged particles, and these particles were later named as electron. In fact, the charge nature or the electrical nature of the particle can be understood by placing the electrical field or the magnetic field perpendicular to the direction of flow of these cathode rays. In both the cases, the bending of the cathode ray is seen, which indicate that these particles, that means the cathode rays, they are charged in nature. That means they've got some kind of electrical charges in them. Also, the characteristic of cathode ray do not depend upon the material of electrodes. No matter what kind of electrode we take and whatever type of gases we take in the cathode ray, the characteristic did not change or do not change. That means these cathode rays, they are fundamental to the matter, or they are fundamentally present in all type of atoms. Thus, we can conclude that electrons are the basic constituent of the atoms, and these cathode rays are merely the electrons. They are the rays of electron moving from cathode to anode. When high voltage is generated, the electrons are ejected from the cathode and they start moving toward the anode. We shall be discussing more about these fundamental particles in our next lecture. By that time, you can read the book to revise your topic. Till the time we meet next, please take care of yourself, keep yourself safe and healthy, and thank you very much.